Now move into the concept of chart projections. Many a times we get a question in our paper related to construction of a Mercator chart. They give us a particular area, coordinates of a particular area, and we are required to prepare a Mercator chart for that area on our answer sheet. So this question is basically not to test our knowledge of chart making, but to test our concepts related to the chart projections. Not that we will be able to make the charts once we understand it, but it will just test our knowledge, and it will tell the examiner that the concept related to the chart projections are clear in the student's mind. So let's see what are the basics involved in a chart projection, chart construction. A Mercator chart is based on two scales. We are aware there are two different scales on a Mercator chart. Let's have a look. You see a small part of the Mercator chart on the screen now. You see a scale on the horizontal side, the bottom horizontal scale at the bottom of the chart, which is encircled, and you see another scale which is the vertical scale on the right side of the chart. Again, it is encircled. So the scale at the bottom, the horizontal one, is known as the longitude scale. The scale, vertical scale on the right side of the chart, is known as the latitude scale. So these are the two scales on which the Mercator chart is based. Now, both these scales are different from each other. That means 1 minute of latitude will be different from 1 minute of longitude. They are not same. It is a property of the Mercator projections that these scales are different. To go a little bit more deeper into the concept of latitude and longitude scale, the longitude scale which you see, 1 minute of longitude or 1 degree of longitude, is constant over the entire chart. So you go to any part of the chart, the length of 1 minute of longitude or 1 degree of longitude will remain same. It is not going to change. Now, with respect to the latitude scale, it is not so. One, which we just now discussed, latitude scale is different from longitude scale, means 1 minute of longitude will not be equal to 1 minute of latitude. Secondly, even after this, the 1 minute of latitude is not even of a constant length over the entire chart. Means if you move to different locations on the chart, the length of 1 minute of longitude or 1 minute of latitude or 1 degree of latitude is going to vary. How does it vary? The latitude scale increases when we go in higher latitudes, or the latitude scale increases while going towards the pole. So as you move away from the equator and you go towards the poles, you will see the length of 1 minute of latitude keeps on increasing. Now we have a relationship between these two scales, that is the latitude scale and longitude scale. The Mercator projection is based on this relationship. So this relationship is the latitude scale is equal to longitude scale divided by cos of latitude. So as is clear from this formula also, you see as the latitude keeps on changing, the latitude scale also changes. So this relationship is a very important relationship to understand the construction of a Mercator chart. So this should be memorized. very important formula as far as the chart projection basics or chart projection numericals are concerned. So in this formula, if you have the latitude scale, using the formula, you can find what will be the longitude scale and vice versa. If the longitude scale is known to you, the latitude scale can be easily calculated. So we will use this formula in the coming numerical. The application will become clear in the mind then.
You can note this formula down, beta, in your notebooks. You can note this down.
Now, before we go into the numerical, let's first understand some of the basic definitions. They really helps us in understanding the concepts as well as in the numerical also. The first definition which we have is the definition of meridional parts, in short also known as MP, Mike Papa. So what are these meridional parts? It is the length of the meridian between the equator and that particular latitude. Meridional parts are reference to latitude. Every latitude will have a meridional parts value. So it is the length of the meridian between the equator and that latitude measured in units of longitude scale. Or you can also explain it in a different wording, in a different way. That is, the number of times 1 minute of longitude can be laid between the equator and that particular latitude. So the number of times you can place 1 minute of longitude from the equator up to a particular latitude is what we call as meridional parts for that particular latitude. How do we obtain them? We have a meridional parts table in the Norris nautical tables. So they can be picked up from there. You enter the table with latitude, and for every particular latitude, degrees and minutes, they will give you the meridional parts for that particular parallel. Now moving on to the second definition, that is DMP. It is difference of meridional parts. The DMP, or difference of meridional parts between two parallels, is the length of the meridian between the two parallels measured in units of longitude scale, or you can have a different wording again as we had in meridional parts. This was the first definition explained in one way. You can also explain it the number of times 1 minute of longitude can be laid between those latitudes. This is known as the DMP, difference of meridional parts. The third definition which comes ahead is the natural scale of the chart. Natural scale of the chart is the ratio of distance between 2 points on the chart and the actual distance between them on the earth surface. So that is the natural scale of the chart.
Okay, so shall we move on to the numerical now, beta?
With these basics clear in our mind, let's now have a look at a sample numerical related to Mercator chart construction. Questions like these, they appear in the exams. So let's see. The question says, construct a Mercator chart from 28 degrees north to 32 degrees north and 015 degrees west to 020 degrees west using a scale of 1:1000 in latitude 30 degrees north. So we are required to construct a Mercator chart for this particular area defined by these coordinates. They have given us the scale of the chart. Now, whenever the scale of the chart is given to us, it will also be it will always be based on a reference latitude, because you see, as we just now saw, 1 minute of latitude keeps on changing as we go away from the equator. So whenever scale is given, it is referenced to a particular latitude. Like in this question, it is referenced to 30 degrees north. Most of the time you will see that the scale is referenced to the mid latitude of the area which the chart is covering. So you can see here 28 to 32. This 30 degree north is exactly midway, but it is not something which is mandatory. This can be any particular latitude. Now let's see how do we attempt these kind of questions. Now in step 1, we have to first calculate the length of 1 minute of longitude on the chart. All these questions related to Mercator projections, always remember that you have to find out the length of 1 minute of longitude on the chart. What will be the length of 1 minute of longitude? Once we have this 1 minute longitude length, we will be able to solve these questions. Why we are interested in length of 1 minute of longitude is, you see, 1 minute of longitude is of a fixed length. So you can go in any part of the chart, that 1 minute of longitude will be of a fixed length. So it gives us a very convenient unit to construct the chart. We cannot use latitude here, because if you measure the length of 1 minute of latitude, it keeps on changing. At the bottom of the chart, it may be something else. At the top of the chart, it may be something else. So it doesn't help us much to construct the chart. Now, how do we calculate the length of 1 minute of longitude? So for this, let's see. We know 1 minute of latitude on the earth is equal to 1 nautical mile, which is equal to 1852.3 meters. It's a fixed length. We know 1 minute of latitude is 1 nautical mile. That is the definition of a nautical mile. And it has a fixed length of 1852.3 meters. Let's convert it into millimeters. Millimeters is a convenient unit to construct the chart on our answer sheet. So it converts to 1852300 millimeters. Now, 1 minute of latitude on the chart will be how long? We can easily find this out. Once you know the length of 1 minute of latitude on Earth, you can easily scale it down and find what will be its length on the chart. So it will be 1852,300 divided by the scale of the chart. So scale basically tells us what is the ratio of a particular distance on the Earth's surface and on the chart. So we have used the scale here. It will give us the length of 1 minute of latitude on the chart. Now from this, we can easily find out 1 minute of longitude. You remember the formula? The formula was latitude scale is equal to longitude scale divided by cos lat. So we have used the same formula here. We had the latitude scale. 1 minute of latitude was this much. We multiplied it, this value 1852,300 divided by the scale. We multiplied it with cos of latitude to get 1 minute of longitude. So same formula has been used here, and we have converted the latitude scale into the longitude scale. Now 1 minute of longitude is also called as 1 meridional part. So once we calculate this, we will have the length of 1 minute of longitude as well as the length of 1 meridional part. Meridional part is nothing but 1 minute of longitude. You can also understand it in this particular way. The gap or area between two meridians is divided into 60 parts. So every part is 1 minute of longitude. Between any 2 degrees, let us say 000 and 001 meridian, there are 60 minutes of longitude. So it is divided into 60 small parts. Now this 1 minute of longitude is known as 1 meridional part. So using this, we can find out the length of 1 meridional part or 1 minute of longitude. This also is a very important relationship. Now, if you want, you can derive it in these 3 steps in your answer sheet. But if you are running short of time, you can use this formula straight away for your calculation. It can be memorized like this, and you can straight away use it whenever required, and you can calculate the length of 1 minute of longitude.
Beta, any doubt in this up to here? All okay, beta? It looks like perfect silence.
सर ये हमेशा एमएमआई लेनी है कैलकुलेशन?
Ask again, beta.
सर ये जो कैलकुलेशन में हम लोग हमेशा एमएमआई लेंगे?
Okay. Beta, if you want, you can take it in centimeters also. But why I recommend mm is कि कई बार जो है ना वो सेंटीमीटर्स में एक्यूरेसी उतनी नहीं आ पाती है. Then you have to go to multiple decimal places. If you take it in millimeters, at the end of the question, it is very easy to convert it, round it off and convert it into centimeters. So that is why mm is taken. But if you want, if you feel more comfortable with centimeters, you can do that also.
अच्छा सर, बाद में कन्वर्ट कर लेंगे.
Yeah, that's right. That's right. Okay. Any more doubt up to here, beta?
No, sir.
Okay. So we have this formula in hand now. Let's proceed ahead and see.
Okay, so again that formula is repeated here. 1852,300 into cos of latitude divided by the scale. Now, what latitude should we be using here in this formula? The latitude which is used here is the same latitude on which the scale is referenced. So you see in this question, the scale is referenced to latitude 30 degrees north. So this is what we will be using in the formula here. So if you put these values, 1852,300 multiplied by cos of 30 degrees, which is our latitude, and divided by the scale, which is 1,000,000, you will get this value of 1.604 millimeters. So we get a value on this particular chart. 1 minute of longitude is going to be 1 meridional part. It will be 1.604 millimeters. So proceeding further from there, 1 minute of longitude on the chart is equal to 1.604 millimeter. Now using this, we can easily calculate what will be the length of 1 degree of longitude. 1 degree consists of 60 minutes. So it will be 60 multiplied with 1.604. 1 minute was 1.604 millimeters. You multiply it with 60, you get the length of 1 degree of longitude, which comes out to 96.3 millimeters in our particular case. Once you have this length, 1 degree of longitude, you can easily draw the meridians on the answer sheet now. So let's draw the meridians. I have first of all drawn this meridian and named it as 20 degrees west. Now the area of the chart which I want to draw, the one of the extremities is 20 degrees west. So I have considered this longitude as 20 degrees. Now I keep a gap of 96.3 millimeters and I draw the second meridian. The second meridian will obviously be 19 degrees west. See, the right side always is the easterly direction. So when you are going in the easterly direction, the westerly longitude would decrease. So the next meridian which we have is 19 degree west. Again, from this meridian, I can draw a length of 96.3 millimeters, and that gives me a point from where I can draw 18 degree west meridian. So we have the 18 degree west meridian on the chart, on the plot. And continuing further, again 96.3 millimeters, 17 degrees west, again 96.3 millimeters. We get the next meridian, 16 degree west, and again 96.3 millimeters, and we get the 15 degree west meridian. So this was the area, the coordinates which we were required to cover, 15 degree west to 20 degree west. Once the meridians are there, based on the longitude scale, which is constant, that is why you see the length between any two meridians is same in all parts of the chart. Now we know the parallels which we need to draw, that is 28 degrees north to 32 degrees north. So my bottommost parallel will be 28 degrees north. So we can now easily draw the bottommost parallel here. 28 degrees north. So let's plot it. You have the 28 degrees north parallel shown in the diagram now. So all the meridians are plotted. The bottommost parallel 28 degrees north is plotted. Now moving further in the question, we now need to draw the parallel of 29 degrees north. Now to draw the parallel of 29 degrees north, I need to know how much distance I need to keep between 28 degree north parallel and 29 degree north parallel. I need to know this is this in millimeters. So how can we obtain this? I am aware of what is the length of 1 minute of longitude. I have already calculated it. What is the length of 1 minute of longitude is known to me. Now, how to find out the length between 28 degrees parallel and 29 degrees parallel? We have a relationship. The difference of meridional part, or in short DMP, between two parallels of latitude is the number of times 1 minute of longitude can be placed between the two parallels is the DMP between them. We had seen the definition of meridional parts. One meridional part is basically 1 minute of longitude, and we had also seen the definition of DMP. So DMP between two parallels is basically how many times 1 minute of longitude can be placed between the two parallels of latitude. So we are going to use this concept to find out where to draw my 29-degree parallel. So what we are going to do is we will find out the DMP between 28 and 29. Now, how do we find the DMP? From the meridional parts table in the Norris table. So from the meridional parts table, if you check the meridional parts of 28, that is 1740.18. And if you check the meridional part for 29 degrees parallel, it is 1808.09, giving you the DMP as 67.91. So this tells us that between 28 and 29,
Sir,
you can place 67.91 minutes of longitude.
Go ahead बेटा.
सर ये नूरिस टेबल तो हम लोग वहाँ पे मांग सकते हैं ना, या अपनी लेके जानी पड़ेगी?
नहीं बेटा, MMD में अवेलेबल होता है नॉरिस टेबल, so you can ask for it.
ठीक है सर, ठीक है, थैंक यू.
Okay, you can ask for it, and if you have your own also, you can carry it along in case the table is in shortage. Let us say too many people are asking for it and then table is in shortage. Then you can ask the surveyor, sir, I have my own, please allow me to use it. They will also allow that.
ठीक है सर, ठीक है.
But make sure it is clean, huh? ऐसा ना हो कि लेने के देने पड़ जाएं.
सर वो तो बचपन वाली है तो पर.
Okay, okay, all right.
This is the definition of DMP. So one meridional part is equal to 1 minute of longitude. So distance between 28 and 29 is equal to 67.91 minutes of longitude. And we had already calculated 1 minute of longitude in this particular diagram is 1.604 millimeters. So we multiply both of them to find out the distance, and the distance comes out to be 108.9 millimeter, or in other words 10.89 centimeters. So this is the distance which you need to keep between 28 degree north parallel and 29 degree north parallel, 108.9 mm. So we mark off this 108.9 millimeter of distance, and after marking this distance, we can now draw the parallel of latitude of 29 degrees north.
Any doubts up to here, beta? Is it clear?
समझ नहीं आया सर, ये एक बार दोबारा बता दीजिए कैसा है 108.9.
Okay, beta, I will tell you. अब बेटा द इम्पॉर्टेंट थिंग टू अंडरस्टैंड इज कि हमारे पास 1 मिनट ऑफ लॉन्जिट्यूड की डायमेंशन है. हमें पता है कि 1 मिनट ऑफ लॉन्जिट्यूड स्केल से कितना बड़ा है, ये हमें पता है चीज़. 1 मिनट ऑफ लैटीट्यूड नहीं पता है हमें, क्योंकि 1 मिनट ऑफ लैटीट्यूड वेरी करता रहता है. सो हमने अब 29 डिग्री नॉर्थ का पैरेलल ड्रॉ करना है. तो अगर मुझे ये पता चल जाए that between 28 and 29 how many minutes of longitude can be placed, तो मुझे डिस्टेंस मिल जाएगा. Is it okay up to here? Did you understand?
Yes sir.
Okay. अब ये कैसे पता चले कि 28 और 29 के बीच में कितने मिनट ऑफ लॉन्जिट्यूड आ सकते हैं? इसको ढूंढना बहुत आसान है. Minutes of longitude which can be placed between two parallels is given by the DMP between them. So हमें इन दोनों के बीच का DMP पता चलना चाहिए. DMP मिलेगा, then that value tells us how many minutes of longitude can be placed between two parallels. So हमने नॉरिस टेबल से पहले इनका DMP पता किया, जो कि आ गया हमारे पास 67.91. So basically 67.91 minutes of longitude can be placed. 1 minute of longitude is 1.604 mm, तो मैंने उसे 67.91 से मल्टीप्लाई किया and I get this value 108.9 millimeters. Is it clear now, beta?
Yes, sir. Yes. Thank you.
Okay, great.
तो ऐसे से सबके लिए अलग अलग निकालना पड़ेगा ना, अभी 29, 30, 32 तक.
राइट बेटा, दैट्स राइट, बिल्कुल सही है. अभी मैं दिखाता हूँ आपको.
Similarly, we can now find out what is the distance between 29 degree and 30 degree north parallel. Now keep in mind that the difference between the parallels of latitude will not be constant, will not be fixed, as it was in the case of meridians or longitude. Between every two longitudes, the distance was 96.3 millimeters. But this does not apply, or this does not happen with parallel of latitude. So as we are aware that on a Mercator chart, 1 minute of latitude keeps on becoming bigger and bigger. So the gap between the parallels of latitude also keeps on increasing as we move away from the equator towards the pole, or as we go into higher latitudes, the gap between the parallels keeps on increasing. So between 28 and 29, we had a gap of 108.9 millimeters. Between 29 and 30, it will not be the same. It will be different because 1 minute of latitude keeps on changing. So how do we find that gap between 29 degrees and 30 degree parallel? We use the same method. We find out the DMP, difference of meridional parts between them. And this DMP now comes out to 68.58. 1808.09 is the meridional parts for 29 degree parallel of latitude. 1876.67 is the meridional parts for 30 degree parallel of latitude, and their difference comes out to be 68.58. Now we know one meridional part is equal to 1 minute of longitude. So the gap between 29 and 30 is basically 68.58 minutes of longitude. 1 minute of longitude is already calculated as 1.604 millimeters. Multiplied by the DMP gives us the gap or distance between 29 and 30 degree parallel, and it comes out to be 110.0 millimeters. You see, it has increased from 108.9 millimeters. The distance has become more. So now using this value, 110 millimeters, we can now mark off the parallel of latitude of 30 degrees north. Similarly, following exactly the same procedure between 30 and 31, we get the DMP between them. Meridional parts of 31 degree, 1945.96. Meridional parts of 30, 1876.67 gives the DMP 69.29. So that means 69.29 minutes of longitude can be placed between 30 and 31. So we know 1 minute of longitude is 1.604 mm. This gives us the gap between 30 and 31 as 111.1 millimeters. So again, you can see the distance between 30 and 31 has increased now from 110 to 111.1. So we can now measure this much of distance, 111.1. And keeping this distance, we can now mark off the parallel of latitude of 31 degrees north. Exactly in the same way, we find out the gap between 31 and 32. The DMP is 70.02. Multiplied by 1 minute of longitude length 1.604, it gives us the length between, or the gap between 31 and 32 as 112.3 millimeters. So keeping this gap between 31 and 32, as 112.3 millimeters, we can now mark off the parallel of latitude of 32 degrees north. And this completes the construction of our chart graticule for the required coordinates. So you can see now, as we go in higher latitude, the gap between the parallels of latitude keeps on increasing. It was 108.9, then it became 110, then 111.1, and finally for 31 and 32, it became 112.3. So this is the construction of a Mercator chart. Now, one thing to keep in mind here is that it is possible that in the questions which you get in the exams, you may not be able to actually plot these distances on your answer sheet. You can see the gap between 20 west and 19 west is 96.3 millimeters. It is 9.6 centimeters. So the total width of this diagram is going to be close to 50 centimeters. So you require a space of about 50 centimeters to make this diagram. And the answer sheet which you have is maximum at the most one page of the answer sheet is about 15 centimeters wide. So you are not going to get the required space to make this diagram in real scale. So in that case, what is to be done? You can make this graticule like this, like the one as shown on the screen. And in the graticule, you can represent all these distances in millimeter exactly as they are shown on the screen in this particular diagram. So this may not be accurate to scale. This will not exactly be 96.3 millimeters, but you can keep it as 9.6 millimeters or 1 centimeter. You can keep it as 1 centimeter and you can mark off all these distances. So once their calculation is shown on your answer sheet and this graticule is made on the answer sheet, the examiner knows that the candidate is aware of how the chart is to be constructed and you will get your marks. If you have time and if it is possible, you can use a downscaling also. How can downscaling be done? Now this gap between two meridians is 96.3 mm. If you use a downscale of 1:10, you can make this gap as 9.6 millimeter. So instead of 96.3, if you take a downscale or down ratio of 1:10, it becomes 9.6 millimeters. So rounded off to the nearest centimeter value, it becomes 10 centimeter. It becomes 1 centimeter. So you can keep it a scale of 1:10 and you can make this entire graticule if you have time. But if you are running short of time, just make a rough diagram of the graticule and show these distances in millimeters, and that will do the job.
So any doubts in this, beta, you can ask me.
Yes, sir. Sir, initially, जो initial part है answer का, उसमें we are using this formula 1 minute of longitude is equal to 1852300 into cos lat.
Right.
तो सर इसमें lat की value का use कर रहे हैं हम.
Okay. Let me show you, beta. Just give me a minute. बेटा जब भी आपको क्वेश्चन दिया होगा, see this is the question on the screen we have. Whenever they give you the scale, like in this case the scale is 1:1000000, it will always be based on a reference latitude. In this case the reference latitude is 30 degrees north. This is to be used in the formula. Okay beta, did you get it?
Yes sir, got it.
Right. Okay. Any other doubt?
छोटा सा डाउट था सर.
हाँ बोलो बेटा.
सर जो लॉन्जिट्यूड है, इट इज एज पर थियरी सर बोल रहे हैं सर कि इट विल बी इक्वी डिस्टेंस side longitude, but sir, actually because it is converging towards the pole, so as we are going higher, the longitude is converging towards the pole.
Yes, you are very right.
तो सर डिस्टेंस हमेशा इक्वल कैसे हो सकता है ऑन एवरी लॉन्जिट्यूड?
ग्रेट, ओके। देखो बेटा, आप बिल्कुल सही बोल रहे हो कि जो मेरिडियंस हैं वो तो जैसे जैसे हम पोल की तरफ जाते हैं वो मेरिडियंस तो डिस्टेंस कम होना शुरू हो जाता है एंड दे गो एंड मीट एट द पोल्स, राइट?
यस सर।
But the thing is, we are not representing the Earth's surface on our diagram. We are showing a Mercator chart of that area. Now, Mercator chart की ये property है कि Mercator chart पे meridian एक दूसरे के parallel होते हैं. That is why there is a distortion in the Mercator chart. So, Mercator chart में ये distortion होती है that meridians remain parallel to each other. Therefore, we cannot show the polar regions also in the Mercator projections. Okay.
Okay sir.
What we are showing here in our screen is the Mercator chart of that area. Okay, beta. All right.
Thank you sir.
Right.